Select the structure of the monomer used to synthesize the following polymer. So we can see in our monomer structure here, our repeat unit, our carbon backbone, is 4 carbon atoms. And another thing to notice is that in this repeat unit, we have an alkene present. In our previous examples of chain growth polymerizations, what we have seen is polymerizations of substituted ethylenes. And in those reactions, the alkene reacts to give you the reactive intermediate, and as you form the chain, the backbone no longer contains an alkene. And so the fact that we have an alkene still present in this repeat unit, this implies that our starting monomer must have had more than one alkene. So our starting monomer in this case was a diene. So what we want to look for is a diene that has these 4 carbon atoms and also has as a substituent the methyl group on carbon 2. And so if we take a look at our 2 diene options, only A has that methyl group on carbon 2. So this is the structure of our monomer, and let's take a look at how this reaction might have occurred. And so this monomer here is actually natural, or this polymer here is actually natural rubber, and it's formed by the polymerization of isoprene units. A here is an isoprene. So that's this 5 carbon atom unit arranged with this iso group here and the 2 alkenes. So if we're taking a look at this reaction, you might notice that this backbone is in the Z configuration. So we need to rotate this bond if we're going to show the polymerization. So I'm going to go ahead and draw the isoprene unit with that bond rotated. So we'll have this sort of backbone. And it doesn't tell us how this reaction occurred to make the polymer. The simplest thing I think to do would be to show a cationic polymerization. And so that's what I am going to do. I'm going to go ahead and protonate this. And I'll protonate on the end where I can get the most stable carbocation to show our first reactive intermediate that could be forming in this polymerization. So we would get the following cation. And so this is the initial reactive intermediate, and we can have this react with another unit of the isoprene. And when it does so, it can do a conjugate addition to the end. So I'll add here and then shift that alkene in. So that's how we end up with our alkene between carbons 2 and 3, when initially it was between, or you had the dienes on the ends and there was just a single bond between carbons 2 and 3. So then we can draw the product of this step. So there's our first isoprene unit, and we now have an alkene here. We can draw our new bond and then the other isoprene unit. And so now we have a new cation, and this can react again and again and again as we form the long polymer chain. So we can do another conjugate addition and so on. And this is how we're going to form this polymer structure.